Good morning, everyone. I am spot on weather meteorologist Matthew Euler. Welcome to my latest Teleconnections Discussion video. This is actually, I put this together late last night, so we'll go ahead and roll through the video here. Starting with what I normally begin with, looking at the Northern Hemisphere, the short waves across the Northern Hemisphere. I'm going to get my pointer out here. Okay, so let's pay attention here to the Northern Hemisphere. Let's look at the shortwave troughs and the shortwave ridges. Just keep in mind that beneath ridges, the orange colors and the brown colors on this chart on the left, that generally indicates drier and milder conditions. If you're located beneath the areas that are green, purple, or blue, that indicates you have an upper level trough over your location. And in that case, you're going to have more unsettled weather and colder temperatures. So let's examine the upper air features here at 500 millibars or 18,000 feet above the surface. And let's start here from the left side and we'll work our way to the right side. All right, so initially we have a closed upper level low, a couple different closed upper level lows, and associated upper level troughing across northwestern and north central Russia. Meanwhile, there's an upper level ridge, which is located over Mongolia in the eastern Russia. Or further to the east, we see a deep upper level trough across northern Japan. And then we have some very strong upper level ridges on the Pacific side specifically, starting with the one just immediately to the northeast of Japan. We have a strong upper level ridge across the northwestern Pacific Ocean, extending northward into the just generally the western sections of the Bering Sea there. Additionally, we see a upper level trough across basically to the northwest of Hawaii. We have an upper level trough at that location across the central North Pacific. And then we see a very, I'll tell you what, this is a really stagnant upper level high that's generally to the west of the California coastline with the ridge axis extending north into the Gulf of Alaska. And this has been a very persistent or stagnant feature for quite some time now. And it's basically resulting in a Pacific block. And in this case, all the storm systems have to go up and over the block, and then they drop back down the front side or the east side of it into Canada and the U.S. So this is a major feature that is really influencing the weather across the United States right now. We see a weaker upper level trough across the Four Corners region, the desert southwest of the U.S. area there. We also see a much more predominant deep closed upper level low and troughing in the vicinity of eastern Canada down through Hudson Bay. And this has also been a very persistent feature. And this is generally associated with more of a positive tropical northern hemisphere pattern when you get a strong or a deeper vortex there around Hudson Bay, Canada. Additionally, we see some tropical ridging there over Cuba, but it's generally really suppressed to the south. We have a ridge axis extending across the far southwestern portions of the North Atlantic. So more of a west to east orientation of the subtropical ridge down to the south from Cuba across the Caribbean. Additionally, we see an upper level trough across the northwestern portions of the Northern Atlantic Ocean. Ridging is generally extending across the central North Atlantic Ocean here. And then we see a closed upper level low and troughing, just generally located to the northwestern portion, just the northwest of Europe. And then we have another trough there kind of digging in through the Mediterranean from France down through the central Mediterranean into northern Africa, followed by a pretty significant upper level ridge, closed upper high and upper level ridging over Kazakhstan. So that's generally what we got going as far as these waves, these short waves in the 500 millibar level across the northern hemisphere as of today. Looking at the Madden-Julian oscillation phases and areas of enhanced convection, the MJO ranges from phases 1 through phase 8. And generally, these convective areas will move from the west towards the east, there in the tropical Indian Ocean, as well as the tropical western Pacific Ocean. And so whenever, each of these phases means something different for the weather across the United States in the winter season. But let's go ahead and take a look to see where we're at. Now we have the MJO temperature composites here on the left for the months of November, December, and January. And blue colors on this graphic here on the left on these plots indicate below normal temperatures. Orange colors indicate above normal temperatures. So let's take a look at the forecast here on the right-hand side. This is the latest Jeff's V12. This is the MJO forecast, and this goes out to the 18th of December. The black line kind of shows the progression of basically where we have been. All right, so that's in the past. We see the black line, that's what happened in the past. The red line and this blue line, and even the purple little line here, that represents the forecast. So Jeff's V12 is forecasting right now we're in MJO phase 8. And what does phase 8 look like? Look at over here on the left-hand side again. A lot of blue color across the northern plains, Midwest, even the deep south, the mid-Atlantic up to New England. Look at this. Below normal temperatures are favored with a trough, upper level trough in the eastern U.S. and MJO phase 8 at this time of the year. And we're seeing that. We're basically seeing that right now. We have MJO into phase 8. The forecast is for the MJO to move into the null phase, the small inner circle at the center of the diagram, between the 7th and the 8th and 9th and 10th, all the way to the 13th of December. And then the MJO, according to the Jeff's V12, is forecast to move back out into phase 7 and work its way back into phase 8 by the 18th of December. Other models at MJO forecast here. On the left, I have the CFS V2 extended bias corrected model showing the MJO also in phase 8 today. And the forecast from the CFS V2 has the MJO working its way into weaker phase 1 and then into this null phase, the small centered circle here, the smaller circle at the center of the diagram, the null phase meaning more non-impactful for U.S. weather. And then the right through the 2nd of January, the MJO comes back out on the border between 6 and 7, according to the CFS. Over in the middle, we have the European forecast, MJO forecast through the 18th of December, showing the MJO in phase 8 as of now, and that is going to work its way into the null phase briefly and then come back out into MJO phase 8. And then over on the right-hand side, we see the BOM, the Bureau of Meteorology model from the Australian Bureau of Meteorology. This is a bias-corrected extended model of the BOM going out through New Year's Eve, 12/31, showing the MJO in phase 8 today, and then kind of looping around between the null phase and phase 8 for quite some time before it moves down into the null area there, the center of the diagram from the 22nd to the 31st of December. So there are differences in the modeling, and we expect that. We look at the Jeffs, we look at the European, we look at the BOM, we look at the CFS, and there are some differences here. I mean, all of them show that we're in phase 8 right now, but where does the MJO loop around, and where does it come back out at after looping around in the null phase? All right, looking at the latest sea surface temperature anomalies across the northern hemisphere oceans. First of all, I want to mention the daily Southern Oscillation Index as of yesterday was sitting at minus 43.70. That is a significantly negative value, and it has dropped off significantly negative recently. Just to think that this was positive about a week ago, and now we're well deep into negative territory. That indicates weakening trade winds right across the tropical Pacific areas, weakening trade winds, which is associated with a weakening La Nina in the tropical eastern and central Pacific Ocean. We do see the oranges and the yellows indicating above normal water temperatures. We see the warmer than normal water there across the northwestern Pacific to the east of Japan. We also see warmer than normal waters across the north central Pacific. And we also see a new development here along the immediate west coast of the United States. We're seeing some warming water temperatures there from just off the coast of Washington State, off of Oregon, and off of California. And, I'm going to be curious to see what happens in this particular area in the eastern North Pacific, since we've had that Pacific blocking high, the upper level ridging for such a persistent amount of time. These little cooler than normal pockets of blue colors in the Gulf of Alaska, Are those eventually going to disappear? And are these water temperatures going to continually warm across the eastern North Pacific due to that placement of that persistent upper level ridge? We will see what happens. But just realize one thing. Whenever you have an upper level ridge overhead over the ocean, there are very light winds associated with upper level ridging. Your storm track is diverted around the upper level ridge, which means there's really not a lot of wind energy being imparted to the waves, to the water surface, and therefore you really don't get much of any mixing of the water, the ocean water, right? You don't get any wave action when you're directly beneath a persistent upper level ridge like that. And what that does, the lighter winds really don't mix the water, and it results in warming waters beneath the upper level ridge. So we're going to have to keep an eye on this and see what happens. How is that persistence of the upper level ridge, the Pacific block, going to impact the water temperatures out there? Um, Additionally, we see some above normal water temperatures across the northern Atlantic. We do have a couple pockets of cooler water, but in general, we see above normal water temperatures there south of Greenland. That's an association with a positive phase of the Atlantic multidecadal oscillation. That generally tends to favor more of the negative NAO phases during the wintertime when you have the above normal water temperatures there across the North Atlantic. We see the cooler than normal water generally really standing out across the eastern and central tropical Pacific Ocean, and then again some pockets here into the Gulf of Alaska. Here are the El Nino Southern Oscillation. These are the intensity classifications, just a brief review of that. And then generally, this is the Nino 3.4 region, this rectangular box here. And this is what NOAA uses to determine whether, what are the water temperature anomalies in this area, this Nino 3.4 region? What are they? And, do we have an El Nino, a La Nina, or ENSO neutral conditions? Looking at the latest forecast here on the left, the mid-November, now there'll be a mid-December one issued out here in about 10 days from the IRI, generally showing a weakening La Nina. The blue vertical bar represents La Nina, the gray vertical bar represents ENSO neutral conditions. And notice December, January, and February, the La Nina vertical bar is just slightly taller than this gray ENSO neutral bar. But then when we get into January, February, March, look at this, how the ENSO neutral bar now grows over 60% probability, and the blue La Nina bar is right around 35%. I'll break those numbers down here in a moment from IRI, but this is a big change right here, right? We see the La Nina, there's signs of it weakening. It's almost as if we've seen a peak in the La Nina. So we'll continue to watch this trend, but I'm still anticipating ENSO neutral conditions by early January. And to kind of back that up, look over here on the right-hand side. This is the model predictions from mid-November, also from IRI. We have the maroon line is the average of all the dynamical models, and the green solid line is the average of all statistical models. And notice we're basically, if you look over here on the y-axis, this vertical axis, these are the water temperature anomalies in Nino 3.4 region in degrees Celsius. And we need minus 0.5 or cooler for La Nina to continue. And you notice November, December, January, that kind of is the peak of where the water temperatures are the coolest. In fact, NOAA, most recently, the Climate Prediction Center said the water temperature anomalies are minus 0.6 degrees Celsius right now in Nino 3.4. So that's not a very strong La Nina. It's very weak. And look at the green, the solid green line, and then that solid maroon line, the dynamical and statistical averages showing the water temperatures, positive slope to these lines, showing the water temperatures going into ENSO neutral territory in specifically right around the January time period. We look at the probabilities from IRI. These are the basically 3-month increments, NDJ, November, December, January, DJF, December, January, February, JFM, January, February, March. These are probabilities for La Nina to occur. These are the percentage probabilities, and this is neutral. So again, November, December, January, we had a pretty strong indicator, 67% chance of La Nina, only 33% for ENSO neutral conditions. Now look at this, December, January, February, La Nina probabilities now decreased 14% down to 53%, and neutral conditions, ENSO neutral conditions has increased to 46%. And then by the time we get to January, February, March, La Nina probability is now decreased all the way down to 35%, while ENSO neutral has really risen to 63%. So this again is where I'm expecting that transition, and definitely by February. I mean, look at this: 19% probability of La Nina is only 76% for ENSO neutral conditions. So there's increasing probabilities for ENSO neutral conditions, definitely beginning in January. We look at the quasi-biennial oscillation, the QBO update from the Singapore radio sound observations. The blue vertical line here, this is representing your phase of the QBO. Whenever this blue vertical bar is to the left of this vertical gray bar, that generally indicates we have easterly. The negative values represent easterly winds in the stratosphere above the equator. So you see we're clearly, the blue line here is clearly to the left of this solid gray vertical bar and the negative side, negative value side, and that indicates an easterly phase of the QBO. Now this favors a weaker wintertime stratospheric polar vortex and a negative phase of the North Atlantic oscillation. And we're already seeing this already. Weaker SPV is already evident. We already see a weaker polar vortex already evident early December with stretching events. And we do expect, the modeling is suggesting another weakening or stratospheric warming in middle December. Now let's look at the actual teleconnections themselves. We'll start off with the AO forecast. When you have a negative AO, this is what happens on the left-hand side. We generally get the upper level ridging across the eastern North Pacific up to the Gulf of Alaska. We see some very cold air coming across Siberia with a negative AO into Canada, and that Arctic air then dumps down into the Midwest, eastern U.S. With a negative AO. On the positive AO side on the right, we see a different whole pattern setting up. Positive AO, we usually have a stronger polar vortex, and it generally tends to keep the coldest Arctic air locked up over the polar areas. With a positive AO, get more of a west to east jet stream, and much milder conditions. Pacific air can really readily move into the U.S. and kind of go from the west to the east coast with a positive AO, so just kind of keep that in mind. You also get a lot wetter. You get some storm systems that come into the western U.S. with a positive AO. Here's the forecast, European EPS AO 50 perturb member forecast, showing a negative AO. Look at the green line. That's the average of all 50 of the ensemble forecast members. We're going to peak at a negative AO right around the 7th of December. Then it starts working its way back up towards the zero line or the neutral line briefly, the 10th, the 11th, but then it drops back negative right on through the basically the, what is this, the 10th through the all the way to about the 16th of December to be negative, and then the EPS is showing a slightly positive AO after that. NOAA Jeff's V12 AO 30 perturb members showing a negative AO as well, with a peak drop in the AO down around the late on the 6th, early 7th of December. And then we see generally it tries to recover towards neutral conditions around the 10th, the 11th of December. Then it works its way back to negative through the 16th and 17th. And then it goes neutral after that, after 17 December. Looking at the North Atlantic oscillation, latest forecast NAO. Here's your difference. Negative NAO on the left, showing a deep upper level trough, digging in. Look at the connection all the way up to these Arctic areas. Look at the purple arrows directing the coldest Arctic air all the way down through central Canada, right on into the eastern U.S. We see a mild air mass beneath this upper level ridging, this Atlantic blocking here across up into Greenland. And we also see typically the negative NAO. Western Europe can get pretty cold too, with colder air moving in on the front side of this blocking upper level ridge. On the right hand side, positive NAO, more of a west to east jet stream with the coldest air locked up over the Arctic area. Here is the European EPS NAO 50 perturb member forecast showing a negative NAO right on through about the 10th, 11th. It tries to go closer to neutral, then it dips back negative again through the 15th of December. And then according to the EPS, the NAO then goes slightly positive, generally after the 15th to 19th December. The NOAA Jeff's V12 showing a negative NAO through 15 December. And, it does briefly try to touch neutral here on the 11th, but in general, it's negative through the 15th of December before recovering to be slightly positive the 16th, the 17th, 18th, and it kind of goes back towards neutral there around the 20th of December. Looking at the Pacific Teleconnections, PNA, Pacific North American forecast, left-hand graphic here showing With a positive PNA, you get upper level heights above normal across the western portions of the U.S. up into western Canada. You see a deep upper level trough in the blues and purple colors across the Midwest to the east coast there. And that's with a positive PNA. And on the right-hand side, we see a negative PNA. It's a flip reverse pattern, troughing and cold temperatures across the western U.S., and you get more of a ridging setup across the southeastern U.S. up to the mid-Atlantic with a negative PNA. Here's the forecast, European EPS, PNA 50 perturbed members showing a negative PNA working its way basically through the 7th of December. Then we see a turn to more of a positive PNA from 8 to 10 December, and then dropping back negative after that through the 19th. NOAA Jeffs V12 PNA 30 perturbed member forecast. This one goes out to the 20th of December as well, showing a negative PNA through the 7th of December, then becoming positive from 8 to 10 December, that very brief window, and then back to negative again after that through the 20th of December. Now, looking at the EPO, Eastern Pacific Oscillation forecast, a negative EPO on the left generally indicates we have a upper level ridge across the northeastern Pacific, and that is to the north of an upper level low or trough there to the southeast of the Hawaiian Islands. So we have negative EPO, think upper level ridge in the northeastern Pacific over an upper level trough. And what this does is this upper level ridge causes a storm track and all the cold air to go up and over the ridge, and you get cross polar flow from Siberia into Canada, right on down into the U.S. With a positive EPO on the right, it's much milder across the whole United States. And look at the northeastern Pacific pressure patterns now with a positive EPO. We have an upper level low. We have a closed low there in the Gulf of Alaska, and that's generally positioned to the north of upper level highs or ridging there around the Hawaiian Islands. Looking at the European EPS, EPO 50 perturbed member forecast showing a slightly negative EPO persisting through today, the 5th of December. Then it goes pretty strongly positive right on through from the 6th to the 12th of December. And then it comes negative again, becomes negative from basically the 12th through about the 18th of December, and then kind of towards neutral after that. NOAA Jeffs V12 EPO 30 perturbed member forecast showing a negative EPO becoming strongly positive from 6 to 12 December, and then turning negative again. And then finally, I wanted to introduce you to the Western Pacific Oscillation, the WPO forecast. Now, this is significantly negative lately, so this is why I wanted to show it to you. This is courtesy of World Climate Services graphic, both of these graphics actually. Positive phase of the Western Pacific Oscillation, okay? It's really a dipole pressure pattern between the Bering Sea and northwest of Hawaii. We're looking at what is the pressure patterns, predominant pressure patterns over the Bering Sea to the west of Alaska and then to the northwest of Hawaii, right? So with a positive phase in winter of this WPO, you see this is showing the peach colors are showing the percent of years having above normal temperatures, and above normal precip would be the green here in the bottom left. So it's generally milder and wetter across the eastern U.S. when you have a positive phase of the WPO. A negative phase in winter, on the other hand, you see the blue colors across the northern plains, the Midwest, East Coast, and you see these peach colors across the U.S. southwestern areas. And so that's the big difference there. Generally, the negative phase of the WPO favors colder temperatures in the Midwest, the East Coast, and then you see a generally near average precipitation. Here is the current values on the right, showing how this blue spike here at the far right-hand portion of that graphic on the right shows we are quite negative right now in the value of the WPO. It has really dropped significantly here in early December. Here is the latest European EPS WPO 50 perturbed member forecast. This is what I'm talking about. We're slightly negative now. We go close to neutral around the 6th, 7th, and 8th of December. But then we turn more sharply negative from the 8th to the 19th of December with this Western Pacific Oscillation, the WPO. The NOAA Jeffs V12 WPO 30 perturbed members, slightly negative to neutral. And then follow this green line, we go deeply negative as well with the WPO right on from the 7th all the way out to the 20th of December. Here is the latest, we look at the polar vortex, the zonal mean zonal winds, and the stratospheric temperatures from Strata observed by Zach D. Lawrence. You see that whenever these colored lines, by the way, these colored lines represent various models, and you see what these models are here. Generally, we see a dip in this line here, indicating a decreasing zonal mean zonal winds there in the stratosphere at above 60 degrees north latitude. So we had a major drop off, slightly negative values back in late November, and now we see a little bit of an increase in those zonal mean zonal winds, but it's not by a lot. Then we saw another little dip right around now. We see another little dip here in the zonal mean zonal winds, indicating weakening of the stratospheric polar vortex again, and then we see those winds increasing over time. But then they kind of dip down again, prior to mid-month. We see the stratospheric temperatures here on the right showing some warming to the stratospheric temperatures through the 5th of December, and then kind of a drop off where they kind of start cooling down after that a little bit. But maybe around the mid-month, we see another stratospheric warming event. Some of the modeling is showing these temperatures warming again. So zonal mean zonal winds is a great indicator of stratospheric polar vortex strength. Whenever these winds are super strong, you look at the values over here on the right. From -5 to 45 meters per second. Whenever these winds are very strong, it indicates a very strong polar vortex. Whenever these winds kind of drop off, it indicates a weaker polar vortex. So there are some indications that we could see some warming stratospheric temperatures and a little bit of drop off or deceleration of these zonal mean zonal winds right around mid-month. All right, I'm going to move on. I just want to briefly mention here, I'm kind of pressed for time. This is the upper level ridging, this maroon color that's just been so persistent off the California coast. This was yesterday, the 4th of December. The purple line here indicates where the polar vortex is basically situated. The purple coloring here, well, we see the core of the polar vortex over Hudson Bay. Over on the right-hand upper right, we see this is the forecast for the 7th of December. You see these upper level lows and these troughs, these cold pools of air, generally across the eastern portions of Canada, as well as there into the southwestern portions of Alaska. But we still see the anomalous upper level ridging and above normal heights across the Beaufort Sea, as well as Greenland. These are associated with the negative AO, negative NAO combination. The overall pattern, though, is really evident. You're seeing over time these troughs kind of move over the top of this persistent eastern Pacific ridge. And so we're going to continually get these short waves that kind of move through the long wave pattern and kind of re-amplify the long wave and bring repetitive cold shots down to the Midwest and East Coast over time. All right, my overall assessment to end the video, we're seeing a negative AO and negative NAO combined with a weaker stretched out stratospheric polar vortex. The MJO is in phase 8, which favors colder temperatures and troughing in the east. We're also seeing that strongly negative western Pacific oscillation, the WPO, which indicates colder temperatures that mean upper level trough to remain in place pretty persistently across the eastern U.S. over the next 10 days. And you really can see the flow of cold air from Siberia right to Alaska, then into central and southern Canada, and then it drops into the Midwest and eastern U.S. So real interesting patterns that we're observing, with the polar vortex, with some of these teleconnections. So we'll continue to watch things closely here. I wanted to get another video out here this morning, but I got to run. But that's all I got for now, everybody. And until next time, take care and God bless everyone.